the awesome opportunity to use logarithms. We're going to spend a little time with logarithms today. Well, I'm thinking about it too. We have a lesson today, we have a lesson tomorrow, we have a lesson on Friday, just like always, you know, it's a lesson. And every lesson has practice problems associated with it. So there are practice problems, I call homework practice problems. There are homework problems listed tomorrow on Schoology. That assignment is due Monday. It's there because it goes with the lesson that we're going to do tomorrow, but I'm not supposed to give homework tomorrow, so I can't make it due until Monday. If you want to do it tomorrow, that's great, but you don't have to do it. Have it done until Monday. Everybody good on that? All right, so here we go. This is a three-part problem, I think, and the first one says, what was the initial population of deer? Read the problem. This is the equation that gives me the population of deer. It says, what was the initial population? Now, we talked about this a lot yesterday. When we talk about the initial value, or the initial whatever, what point on the graph are we talking about? We're talking about the y-intercept. The y-intercept is the value of y when what? X equals 0. So we're talking about letting t be 0. This is going to give you your initial value. This is not your initial value, is it? What's that number? Limit to growth. That number tells me that wherever I am, Benjamin Harrison State Park, I can't have more than 1,001 deer. That's going to be the limit right there. That's not what the question is. The question is, how many deer did I start with? So I'm going to put in, I'm P of 0, so I'm going to put in 0. All right, what happens when I put in 0 right there? This becomes, well, that becomes 0, and this becomes 1. So I have 1,001 divided by 91. So that will tell me how many deer I had to start with. Now, because this is a deer problem, let's just round it off to the nearest deer. Oh, that actually goes in nice, that's 11. So whatever this is, game preserve, whatever, there were 11 deer to start with. Everybody got it? Okay. Next question. When will the number of deer be 600? So what do I do? This is my equation. What do I do?
Put it equal to 600.
Put 600 where? 600 doesn't go in for T. T is the time. If I put 600 in for T, that would be like 600 days, right? Or years, or whatever the time unit is. That's not what's happening here. Where does the 600 go? Right here. So I'm going to solve this equation. All right, so here we go. How are we going to begin solving this equation?
Solve the bottom.
We're going to bring this guy over here. So we'll have 600 plus 54000 e to the negative 0.2t equal to 1,001. Bailey?
Can you not combine the 90 and the 1?
No, because the 90 is attached to this. So they aren't like terms. It's like 1 plus 2x. We can't combine the 1 and the 2. So, bring my denominator over to here. Okay, now what? Subtract 600.
Yeah.
How do I get that? I don't know. Now what? You know you've done this before. Emma?
I'm still back a step. Where did you get 54,000?
I'm multiplying both sides by 1 plus 90e to the negative 0.2t. I have to distribute the 600. 600 times 90. I'm multiplying this whole denominator over here to this side so that I can start solving the equation. Mahela?
You plug it into your calculator.
Not yet.
Divide by 54.
I gotta divide by the 54,000 number. I am definitely gonna go to my calculator, but I have got to divide first. Do not let the weird numbers mess you up. We did this a couple of times yesterday, this exact same process, and you floated right through it. They were all whole numbers. Don't let the fact that you've got e's and decimals mess you up. It's exactly the same. You have to divide first. Now, your variable is an exponent. If this were a problem like 2 to the x equals 8, we would not have a problem. If we had 2 to the x equals 8, everybody would look at this and say, oh, x has to be 3. We have exactly the same scenario here. Something to a power equals a number. But there's no easy way of seeing what that number is, right? We could trial and error it, guess and check. You'd eventually get it. It's not a huge, horrible ordeal with a calculator. But if we are willing to use logarithms, we can solve this real easily without all that guessing and checking. Does anybody remember how that works? Logarithms are used to solve equations where the exponent is a variable. If the exponent is the variable, you're going to use logarithms to solve the equation. Does anybody remember how that works? What do we do first?
I'm not like sure, but isn't it like you put in the ln in your calculator and then that gets big and then you like move the other thing to the other side?
Okay, I think you kind of know actually what you're talking about, Lily. I think you're right. We're gonna, first of all, you said ln. We have a choice. We can log, we can use logs, or we can use lns. Why did you say ln?
Because it's on the calculator and I know where it is. I don't know.
Well, log is right about that, so I know where that is too. But why is ln a good choice in this problem? Because there's e in the problem, and ln is a logarithm with a base of e. So it's a good idea to take the natural logarithm of both sides. So we're just going to take the natural logarithm of both sides. You did this last year. Do not act surprised. Now we're going to spend a little more time talking about this today, but there's actually something very special that happens right here. There is a property of logarithms that says, there are lots of properties of logarithms, but there's one that says the log base b of b to a power is the power. So the log base 8 of 8 to the 4th would be 4. And the log base 12 of 12 to the negative 3rd would be negative 3. So the log base e of e to a power is just the power. So this mess right here looks so very complicated. ln is log base e. So what does all this just end up equaling?
20 -2.
Negative 0.2t. So that side of the equation is negative 0.2t. Because there's a property of logarithms that says when the base of the logarithm and the base of the exponent are the same number, the answer is just that exponent. So ln is log base e. I'm assuming you remember that. So log base e of e to a power is just the power. This, Lily said, we're just gonna type it on our calculator, and she is right. T is gonna be the natural log of 401 over 54,000 over negative 0.2. That's gonna tell me how many years it'll take to have 600 deer. Let's see what we come up with. I got 24 and a half. Anybody match that?
Yeah.
Is that years? Yeah. We're gonna do another one. Don't panic. We're gonna spend some more time on this. Don't panic. Okay, 24 and a half. Everybody getting that on your calculator? Okay, good. Now, let's try another one where we need logarithms. Let's look at number 40. Same page, number 40. Give me a formula again, so I don't need to worry about writing it. Oh, help me. Wait, 1, 2, 3. 1, 2, 4, 6. Read the problems, one sentence. What does this formula give me? What's this? What's this stand for? Read it. What's it stand for? The amount of, that's the amount, the number of grams of carbon after we wait T years. Okay? One simple question, what's the half-life? What's the initial value? How much carbon am I starting with?
20.
20? If I'm talking about half-life, how much carbon do I want to end up with? 10? So I want to have 10 grams of carbon. And I need to know how long that's going to take to get 10 grams of carbon. Would you agree that that's really what the question is asking me? How long do I have to wait to get 10 grams? Just like this question said, how long do I have to wait to get 600 deer? This one says, how long do I have to wait to get 10 grams, okay? Step 1.
Would you put ln to both sides?
Not yet. There's something I have to do before I take the logarithm of both sides. Divide by 20. Now, I am definitely going to take the logarithm of both sides because where's my variable? In the exponent. And when my variable is in the exponent, I'm going to use logarithms eventually. But I'm not going to use logarithms until I divide by this number. Notice, didn't we do the same thing over here, kids? What did we do before we put in our LNs? We divided by our 54,000. You have to divide by that number before you take the logarithm. Now, I'll take the natural logarithm of both sides. I'll ln both sides. And what absolutely magnificent thing happens over here? That just equals, this cancels, that just equals negative 0.0, the exponent. So how will I get my answer?
Divide the exponent.
I'll take ln 0.5 and divide it by that decimal. And by the way, when you hit ln, your calculator automatically puts in those parentheses. Be sure you close them before you hit divided by. I got 5,700 years.
You got divided by 5, so this will turn into an L and L on this side too.
Want to do a couple other things, and then if we have time, we'll do a couple more word problems. Anybody have a question about this one before we move on to the next thing? Just want to practice a little bit more with your exponent, or with your logarithms. So I want to do some together in class. Look on page 308. And I'd like to do these first ones together. So number 1 says the log base 4 of 4. Anybody want to hazard a guess? What'd you say? 1. Why is the log base 4 of 4 1? Because we have a property that says the log base b of b to the n is n. So the log base 4 of 4 to the first is 1. Perfect. Beautiful. How about, number 2 is a tricky one. What do you think? Log base 6 of 1.
0.
Who said that? Mr. Taylor, why do you believe it's 0?
Because when any number has an exponent of 0, it ends up being 1.
So Matthew says, I'm going to think of that 1 as 6 to the 0. Can he do that?
Yeah.
And therefore, the answer is 0. Beautifully done.
Can you explain that again?
Any number to the 0 power is 1. In order to use this property, these two numbers have to match. So he said I'd have to rewrite 1. I can't have a 1 there, I have to have a 6 there. So 1 is what power of 6? It's 6 to the 0. It's exactly what we're going to do in number, somehow I turned the page. It's exactly what we're going to do in number 3, because it says the log base 2 of 32. Well, how are you going to think about 32? 32 is 2 to the 5th. So what's the log base 2 of 32? 5. How about number 4? 4. Why is it 4? Because 81 is 3 to the 4th. So we have the log base 3 of 81. 81 is 3 to the 4th. So the answer is 4. Okay, now what about 5? Let's think about that for a minute. It's the log base 5 of the cube root of 25. Now, what's a cube root mean?
5 to the 1/3.
Well, it'd be 25 to the 1/3. Remember, radicals are fractional exponents. So this can be written as 25 to the 1/3. Now what about 25? It's 5 squared. So we have the log base 5 of 5 squared to the 1/3, which is the log base 5 of 5 to the 2/3. So the answer to the question is 2/3. What about 6? Take it one step at a time. First of of all, it's 1 over. Oh, first of all, it's got a radical. What am I gonna do with that radical? 36 to the 1/5? You okay with that? But it's 1 over. What does that mean? That means it had a negative exponent. That's how it got to be 1 over. We're getting close. What's 36? 6 squared. So we have the log base 6 of 6 to the negative 2/5. You okay with that?
Would that
Negative
entire thing be
2/5.
the answer?
Huh?
Would that like log base 6 of 6 to the 2/5 be the
The
entire
answer is negative 2/5.
Oh, okay.
The log base b of b to the nth is n. That's the answer. Now, number 7. What's missing in number 7? What's not there? The base is not there. It actually is, kids. Just like ln means log base e, log means log base 10. It's understood. There's a 10 here. They'll never write it. You don't have to write it. You can if you want to remind yourself. LOG means base 10. So this problem is the log base 10 of 10 cubed, which is 3. What about number 8? Same thing. That'd be the log base 10 of, what's 10,000? 10 to the 4th? Does that be 4? Emma?
When something is base 10, does that mean after you reach like 11, it starts over again?
Yes. When we talk, if you're talking about like a base 10 number system, logarithms have bases, just like exponents have bases. So that's a different conversation. But when we say our number system is a base 10 number system, it means we have 10 digits, 0 through 9. And any number after 9 is written then as a combination of digits. So 10 means a 10 and no ones.
Okay.
Yeah, that's what base 10 means.
Okay.
Okay, what about number 9? Quickly, let's see if we can get through the rest of these. Number 9? The answer is 5. I don't know if anyone's paying attention or not. Number 9 would be the log base 10 of 10 to the 5th. So the answer would be 5. What about number 10? 10 is negative 4. Log base 10 of 10 to the negative 4. What about 11? 1/3. Very good. How do we know that? Because a cube root means a 1/3 exponent. Number 12, be careful. There's a lot going on in number 12. First of all, take care of the radical. So that's going to be 1 over 1,000 to the 1/2 power. Now, what does the 1 over do? Means we had a negative exponent. So we have 1,000 to the negative 1/2. Nothing works, kids, if these two numbers don't match. So what's 1,000? 10 cubed. So what's our answer going to be? Negative 3/2. Now, 13, do not be confused. What's ln the symbol for? ln is the symbol for log base e. So what is the answer to number 13? 3. What is the answer to 14? Negative 4. 15. Negative 1. Why is 15 negative 1?
Because there's a 1 over it.
because it's 1 over. So that's gonna become ln e to the negative first. Yep, that's exactly right, Sarah. Okay, 16, here's this 0 again. Let's see if you were paying attention to Matthew earlier. It says we want ln1. That's log base e of 1. These two have to match. So you're going to have to rewrite that 1 as e to the 0. Can we rewrite 1 every time as something to the 0? Yes. So that's how you're going to handle these 1s. You're going to rewrite them as whatever your base is to the 0 power. And the answer will be. How about 17? 1/4. Very good. 18. Be careful. There's a lot going on. Take it one step at a time and you can figure it out. Radicals do not live well in logarithm land. So I suggest you always get rid of the radical. We'll write that as e to the 7 to the 1/2. Radical means 1/2. So we have 1 over e to the 7/2. What are you going to do next?
Negative.
Make it negative because it's 1 over. So what's the answer to the question? Negative 7/2. Now we're going to do 19 through 24. They look so complicated. But I want you to look at number 19, and if you had to guess an answer to number 19, what would you say? 3, and you would be right. There's another property of logarithms. It says b to the log base b of x equals x. When this number and this number match, that's your answer. So look at number 20. 5 to the log base 5 of 8. 8. 10 to the log base 10 of 0.5. 0.5. 10 to the log base 10 of 14. 14. E to the log base e of 6. 6. E to the log base e of 1/5. 1/5. Easy. So far we've got a couple of properties of logarithms under our belts and we've practiced. All right, we're going to do one more word problem. And then actually, let's get our test back and then I don't have to do that back.
I got 70.